Okay, here we are sure this is set to off and this is set to what? Set to off. All right? All right. Both are set to off like this. Yeah, so we can work properly. Ask him that I want it online. But I'm not going to get you what? No, what? Let me come and look and press on it. Yeah, that's it. Let it start. Okay? Okay, look, as is. Here, there is no connection because some people told me that when you set it to off, it brings the connection. You have 3 modes here, right or wrong? You have off, on, and out of service. Off means you're working normally. Let me tell you the things I've tried. If you're connected here and set the channel to off, it means you need to switch to another side. We need to close it. Close the fiber between the two. If there is no fiber like we operated, we close the differential. There is no fiber in the differential. There is no fiber in the differential. Not good. This is originally, or we will see it now, the fiber, or this is not present outside, so it doesn't get a channel among them. It's not even considered to be present in the system. Is it true that it's an out-of-service issue? No, this is an out-of-service issue. This is not considered an out-of-service issue, as you are doing 2 out-of-service issues, 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 as you are doing 2 out-of-service. But you use it because it's local, but for it to work, you're local, but you have it. Okay, so look, if I came here, I did this, for example, on. Of course, like this, oh. Look at what the meeting gave. Where did I send it? Meaning we don't have it at all. No, look at the internet. RIP remote. Okay, leave it. Off. Like this, it's done. Okay, but the internet. We'll see the effect of 0.4 repeated 7 times. Ah, you didn't see its effect. So here you are. This is all 0 except for what? Will we start to get the gradient, or on whom? On visa rate? And we would like to know what's happening in the area. I estimate it like this. It's 0.4. It aligns with you. Trip and trip L1 start and start L1. And here it became trip. All right? Trip with the system itself. This system sends you like this. All right? And I mean, all right, okay? And we tested the minimum value. Now we want to take a look and get the Excel sheet so that instead of calculating it ourselves, we can see it. The calculation is this. Is this the wind? Yes, this is the wind we have. This is 0.4, end of section 1 with 1.25, 3, 40%, 80%. Correct, great. Now let's choose the I bias in section 2. For example, we choose an I bias of 1.5. So we choose the 4 at what point? At 0.5. At 180%, correct. Nice. Then you come to choose the I bias in section 2. For example, we choose I bias at 1.5, so it should be at what? Now, the 0.4 is section 1. Now we are in another phase. You are at 1.5 over 1.4. Yes, pay attention. Any other phase is not the red, not the bias of blue. Yes, the red is not the bias of yellow. The highest phase, that's it. Because in micro, it might tell you that the red's bias is yellow and the yellow's bias is blue. We have nothing to do with that in the cell. But when you are in test mode in the cell, yes. Okay, now bring the 1.5, color them on the blue phase. But when you come to inject, of course, the blue phase here is naturally unstable. We feel a deficiency in it. You participate by raising the hand from 0.5 to 0.50.
Where is his team? What about his team? We can see it here online. We'll open it here. Where is his team? And put next to it his thing? It will be small. I'm done. I'm trying. I'm on Visa Blue 1.5. But, okay. I'll go to the Excel sheet for the calculation. For example, we put his bias at 4. Just make it 3.5. So here it works. At 1.5. So I put on Visa Blue, which is considered my bias. I put 3.5 amps on it. I can open the team, but it will be a bit small. So you put the fridge like this and the other screen in front of it. Small, right? We will solve every problem that comes up online. You open the two screens next to it. It's small, leave it, it's not a problem. The difference is simple, you understand. Bring it, because before I wasn't looking, but with what remains, it didn't work at how much. It worked at 1.5, so your Visa Blue is also connected. It will raise Visa Red to 1.3 or 1.4.
Yes, correct. I have 1.5. Let's not forget that the first videos work well. Yes, how did we finish now? Do you want me to do anything? The ID minimum high. The ID minimum high, that's the switch? Yes, let's set this time to 1. Let's fix the high differential with its slopes. We want to work on the ID minimum high. Look at this. Let's set this timer to 1. At 1 second, which is for the ID minimum, I will come here to the second page. I will use my output contact now, and then I will come here to the second page. I will inject phase blue at 0, phase yellow at 0, and I only have phase red left, which I will inject now. We said the ID minimum high works at the moment of switching, right? Right, great. So now look, you have the ID minimum at 0.4, the ID minimum high at point A. So you are now, as soon as you set it to 0.6, the device considers it a switch state. So it will set it to 0.8 and then to 0.4. It will see that 0.6 is less than 0.8. So it won't operate at that level, but 0.8 will operate for a full second. After a second, it will release 0.8 and return to 0.4. If it has a photo relay working in this manner, it will operate after a second. Exactly a second for the 0.6 analysis, so we raised it to avoid reaching 0.8. What did we do? We raised it slightly, for example, now it's 0.795. Then we raised it to 0.799 for a second. The first time we raised it above 0.8, like 0.802 for a second, then raised it to 0.805, for instance, it requested instantaneously. Why? Because your word is above whose word? Above the ID minimum high, meaning it switches on, it must be less than that. I'm giving you an example. If you remember, like the ceilings exactly, you now have 0.4 here and 0.8 there. Before, when we were between them, it would work after the ceiling time, which is 0. Now, we are above two thresholds instantaneously. This is what we did to achieve a stack between them, because it switches after the second, which is this time. You will raise it one by one until I see it. You will see it instantaneously to get the word of the undistortion condition that I have been sitting on. I will come to get the point 0.805. Yes, I am just getting the word, so you see 0.805. Now, the unrestraint is irrelevant because it's a bit high. Let's see who is affected by the charging current. We will now turn it on and send it. Okay, boss, because it will start to shorten with you. I will show you everything now. We are here. And it's beneficial to have it with you because it will start to shorten with you. I will show you everything now. Oh, her daughter. Her tears mean they're asking for money. With it, we will tell, execute, respond easily, and bluff far. In a picture, I will start from a response. I will start Guardiola. I will start from a level. For example, like this. For instance, I came to the... It didn't work. Okay? Why? Because at 0.4, the process moves on its own, even if it's 0.2. Okay? But when it reaches 0.4 inside the device, who is this? This is the differential that moves, so it moves. Because we said under undisturbed normal condition, right? Am I wrong? He told you it will measure the fundamental frequency component in the undisturbed normal condition. Will you raise it like this? It is part of the artistic frequency applications. In the case of undisturbed normal condition. As soon as you possibly can get to 0.8 to your work duties, I won't show you Abu la Bishde. Is that it? This is the straight weakness, right? Isn't it? Choose this option. Here now. Choose this one. Here too. The normal one. You take Uber into account always. And forevermore so, choose this option again. I said that the... Is it supposed to work with me? No. Consider the dilemma that we made the time of Russell's summer. So, the question is, if I have 0.6, will it work with me? Or will it consider that there is 0.4 with charging current and not work? So why are you prophetic? So Mr. Lamp, you will come here. Does this 0 confirm it? No, it does not. No 0 confirms it. How do you confirm the 0? Now, no 0 confirms it. How do you confirm it? 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 Does this achieve a win for me on the ampere response? This one from 0.8 is to prove to you, look, it will fly from instantaneous. There are no problems or concerns in any way when it has a thermal charge that does not require immediate or instant action at all. Why, you might wonder? Because we said that the thermal charge, the sentence we mentioned on the occasion, will thoroughly test it carefully by removing the fundamental frequency component under the condition of thermal charge. So look, the CIB for it starts approximately about 50 milliseconds from the moment of closing. This means if you place any load over 50 milliseconds, for instance, say 80 milliseconds, what happens? What happens? Yes, if you take this point or 8, okay, just to be absolutely clear. After that, look at it like this. What will it do? First, you set the time between them, right? Is that right or am I wrong? He wants to see us switching like this now, as soon as you close it now at 0.6. For it, the ID minimum high is the one that's active. How long will the total be written for? 80 milliseconds after 80 milliseconds? No. No. It will be. Exam 2.4. Okay. After 50 millu from the moment of the lock you made, it is considered that it is the same as it is in the hour in under statistic condition. Okay, after 30 manual maximums, how this will happen is that it will release the ID minimum high and return again to the mean. The ID minimum will find that everything is greater than the mean of the ID minimum, but for it, the 0.6 is not entirely differential. So you find it doesn't react. You understand me? You need to reach the mean of 0.8. No. For example, I make it 40 miss. If it's 40 minutes, no, why 40 minutes? Because for it, it hasn't reached. The specifications shape is the switching. For it, it reaches the set point, then it remains silent at 50. When I adjusted the 80, 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 this interim state. My state is the ha 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 ha. Leave this one, just let Azuz water it. Without the full amount, we won't lower it. Look, Azuz, this is the 0.4, which is its syringe. And this is the 0.8, which is the minimum ID here, okay? So, you will analyze it as it is here, okay? This minimum ID is if it's at its maximum, you set its time to 0, as if it has nothing. It's not present. It's true that there's a mistake. You and your exam from the second page, anything greater than 0.4, not 0.6. Why? This is for the device in switching mode. It operates directly on the soil. I won't consider who. The charging car or what? You and your exam directly from the second page, anything greater than 0.6, no. I'm telling you this because I can't leave the video. Don't focus with me. No. Because this, danger. We want to play the video so you can understand while you listen. Why? Focus with me. The first case is that the ID minimum is 0.4. The ID minimum is high at 0.8, but at that time it's 0. So it's as if it's not present, so forget it. Especially from the diagram I named for you. If you switched at a value of 0.6 amperes, the device will trip instantaneously, right? Is that clear? Why? Firstly, the ID minimum high is not active with me. Only the I minimum on the line is active with me, so I really need to be above it. You might ask, why not consider the charging current? I'll tell you because this is not a steady state condition. What is steady state? After 50 milliseconds. Good. If it's the same case, focus with me. We have set it to 0. What is 0? If you actually come to the first page, for example, point 2, any point, and on the second page, it was 0.6 above the differential comet. But on the first page, it was above 50 milliseconds, which is above 3 cycles. For example, let's say 4 or 5 cycles, anything. 6 cycles. Is that clear? On the first page, it's 0.2 amperes, less than the ID minimum. And on the second page, it's 0.6. So, for him, the ID minimum on the first page showed that he had a current above for 6 cycles, meaning for 100 milliseconds. So for him, it was after 50 milliseconds, but he was in 3 seconds. So he subtracted the 0.2 by himself. When he saw 0.6 on the second page, it didn't work. I understand you got me, but just to make sure you are not absent from here. Here, if you had achieved another page, it would work with you. The Stannis is not someone's Stannis wants to test how much this is. Test it in another way and leave this timeline at 80 milliseconds, but try which is greater than 50. So for you, the drawing I made for you now, what is it about? Now I will write with you because its time is 80 milliseconds, right or wrong. You injected the birds above 0.4 and it will decrease from 0.8, which was 0.6. But when you came to inject with the setting in front of you, the ID minimum high, which is 0.8, is what you write with at the moment of switching. For the duration of the 80, from the 80 and 50, then from the charging pay. So after finishing the remaining 30 of the 80, it only had 0.6, but it had the charging pay. So it subtracted 0.4 from it, and it didn't see anything. So you come and say what, and it doesn't get mixed up with you. So when did you arrive? I did a charging job, and it grows normally after 80. Charging job normally after 80 grows in the same state, 0.6 with everything. It just blocks the duration of that time. It's not a block, it activates this new setting. So, what's below is as if it doesn't exist. And it starts from my opinion, who and who. It flies with you after 80 milliseconds. Okay? The charging current is now off. Now let's look at who. At the second harmonic, remove the yellow phase and make a jumper here between the yellow and the red. Okay, let's come here on page 7. We set the frequency I2 to 120 and return to the second page. We plot the harmonics of approximately 1 ampere on the red phase. We plot the harmonics of exactly 1 ampere on the red phase. We plot the harmonics of 1 ampere on the red phase as follows. We place the natural setting. First, high trip on the red phase. We raise the limit above 0.1, remove the trip from it, set it to 0.4, ensure you are within the trip area, come to the blue phase, and increase the current. With the same development, it does not trip. Come on, Visa Blue, lift the pilot! And when you reach 0.4, the blue phase here has a start, but it won't trip, right? Yes, It raises the blue phase, yes, it raises it until it reaches 1. And a quarter, as we mentioned, or when it reaches 1 and a quarter, meaning the bias current, which is the highest phase, which is the blue phase, 1 and a quarter, removes the harmonic distortion, considers it not written, so you find the blue phase drops and the red phase also drops. And it doesn't just consider the static harmonic distortion as non-existent, even though you currently have static harmonic distortion, but it considers it as not present. Look, Mr. Anas, if you come here to the small stone, you understand the information you told me that the two are not linked, that this one blocks the aspect. Yes, that's very informative German. I will try, we haven't tried it yet. Turn this one on and turn this one on. We want to operate both on, so I am and. It's actually blocking the view, which means it's obstructing or hindering the sight, but you didn't notice the lamp from the block's edge because it was cleverly camouflaged or blended in with the surroundings. Yes, that's the thing we originally wanted to test, which was to see if the lamp's design could effectively go unnoticed in such a scenario. The number 443, which is significant in this context, where did this last one, referring to the final piece or component, drop the channel, meaning how did it lose or disconnect from the communication or signal path? There is no step in transitioning to the transition. To the transition. Oh, you're just chilling, not working or anything, no planes or anything. Understand me, I don't work, but here, don't bury this block, it's working. So here you need to take these two as indigenous. As you understood, you reached what's on your block, your episodes, no problem. Okay, so what's left here? Here are two parts. One part in the common. Really? The test mode. The test mode here is that you can write the test mode through the test switch, take a binary input to write with it. Either you enter the relay into test mode. To unlock it, I want to say it, to make it clear in the video, okay? You will enter here from the menu in the relay and go to the word test, and then at the very end you will find what's inside the line differential test. You will enter the line differential logic. You can press enter and then press release local and press block all and press release local 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 and press release local. And so, I mean, here you tell me, do you understand me? Then you go like here. It works on both sides, right? It works on both sides. So you want to test what you have here, but what do you tell me? It won't go away. No. But then you come here, look, you will enter here in the function status. And you enter. As one like this from the junction, you continue. And you don't go into the chaos. You have the definition here as well inside. But what happens from it is that there's nothing, it doesn't have anything to fix it. Oh no, you enter into, and you enter, for example, into a zone. You will enter, for example, the distance from inside, like a block, but you will tell it yes or no, just to remove it also from the test mode. But test mode kills the entire relay. But once you start, you enter the menu as we agreed from the test, no problem. Test line differential test and line differential logic, and from inside line differential logic release local, you remove it from the custom because the communication is working in every case. So for it, communication is not failing. If you entered and test mode due to communication is not there, okay? But I think that's everything related to line definition.